All right, let's look at net ionic equations. This way here. So, with net ionic equations, these used to be a lot harder on the test, but now they've really boiled them down and given you some ways of doing it. I also included a POGL here. There it is. We'll be doing a POGL to help you kind of understand these as well. We've got lots of practice with these, probably over practiced, but it is a critical part that does come up every year on every AP test. So this represents really what's going on. It gives you focus of what chemical species were actually involved. Since most is not changed, so they kind of highlight that. So you always need to start off with a balanced chemical reaction. You should be able to balance equations from regular or honors chem. Often they're double replacement reactions, so that's a compound and another compound, to where you usually switch the ions and you get two new compounds. Very systematic, usually generally very simple. We also have ones where water is produced and others, so you'll see some in the labs as we come across and through our practice. All aqueous ionic compounds into their ions, careful to watch the amounts. So if you have something like a BaCl2, that you get 2 chlorides from that. Solids, liquids, and gases remain. Those will just stay as they are. So one of the things that comes up is things like solubility and precipitates, but I've got a clue for that comes directly from AP itself. You're going to cross off the ones that are the same on both sides of the equations, leaving the others. The remainder is the net ionic equation. You should have done some of these even in regular chem. So one of the things that it says in the unit at a glance that I get from AP is this statement here. It says rote memorization of solubility rules other than those implied in this standard will not be assessed on the AP exam. And in that standard, it says all sodium, potassium, ammonium, and nitrate salts are soluble in water. So what I take that to mean is that if you have other salts and you're not sure if it's solid or aqueous, if it's something other than these, consider it to be solid. So we see in this example, the chemical equation, you have potassium chromate, which is aqueous, barium nitrate, which is aqueous. Put them together, you get barium chromate, solid. That fits our rules because it's not any of those. And potassium nitrate, which it is potassium and nitrate, so it's aqueous. So this, even if you were given just the reactants, making the products is one part of it. Now, when we think of these chemical equations, keep in mind that with all of these, you might be even given these. So you could be started with this. You maybe have to balance it and separate it. So, but you're already given states of matter. So sometimes you're already given a simpler problem because it's not just this by name and you go. You have your complete ionic equation. So that's all of the aqueous broken up. You see how it's a 2-to-1 ratio, 1-to-2 ratio. That stays solid, and those get broken up. We have our spectator ions as nitrate and potassium ions. They should be equal amounts on both sides, so you cross them off. And you get your net ionic equation, really just shows that the chromate ion comes with the barium ion to make barium chromate as the solid. And that's it. So you'll be getting lots of practice. Please ask questions as they come, and I'll catch you on the flip side.